Okay, let's look at an example of how to calculate uncertainty. Let's take an example of density. So let's suppose we want to measure the density of something like a cylinder. Now, to measure the density, we have to measure the mass and the volume, and we can indirectly measure the volume by measuring the dimensions of the cylinder. So we might measure the mass on something like an electronic balance, and let's suppose that we do that and we measure the mass to be 15.00 plus or minus 0.01 grams. So we're saying that the best that the balance can give us is the mass to within 0.01 grams. Could be something between 14.99 and 15.01. We might use a ruler to measure the diameter, and in this case we've measured the diameter to be 1.1 plus or minus 0.02 centimeters. That's really the best I can guarantee that the diameter has been measured, to within 0.02 centimeters. And we do the same thing to measure the height, and we measure that to be 5.00 plus or minus 0.02 centimeters. So let's start just by, it's easy enough to just calculate the density. That's mass divided by volume. Now the volume of a right cylinder is given by pi r squared, and the radius is half the diameter times the height. So this becomes 4 times the mass divided by pi d squared times the height. So we have the numbers. Let's plug them in. This is 4 times 15 divided by pi times 1.10 squared times 5.00. So let's take a minute and calculate that on the calculator. That's 4 times 15 divided by pi divided by the diameter squared divided by 5 again, and we get 3.16 grams per cubic centimeter. Okay, so now the question is, what is the uncertainty in the density? That's really what we want to know. And by the way, I can only use 3 significant figures in the answer because I'm limited to the 3 sig figs that I got in both the height and the diameter. So I have to cut my answer off at 3 significant figures. So let's now calculate the uncertainty. And we can calculate the fractional uncertainty in the density goes as the fractional uncertainty in the mass plus the fractional uncertainty in the volume. The fractional uncertainty in the volume goes as twice the fractional uncertainty in the diameter, and it's twice because the volume goes as the diameter squared, so we have a factor of 2 here, and the uncertainty in the height. So the uncertainty in the diameter, in the density, will be then this quantity, the uncertainty in the mass plus twice the uncertainty in the diameter plus the uncertainty in the height, times the calculated value of the density. We've got all the numbers again. Let's put them in. This is 0.01 divided by 15 plus 2 times 0.02 divided by 1.10 plus 0.02 divided by 5.00 times 3.16. Okay, so we'll put all that in the calculator. 0.01 divided by 15 plus 2 times 0.02 divided by 1.10 plus 0.02 divided by 5 times 3.16. And when we do that, we get 0.13. And this is grams per cubic centimeter. So I would report the density, therefore, as 3.16 plus or minus 3.13 grams per cubic centimeter. And what we're acknowledging here is that our density could be as high as, let's say, 3.29 and as low as 3.03 grams per cubic centimeter. The uncertainty in the density is related to, it follows from the uncertainty in each one of the measurements. And we've propagated those uncertainties through to a result. That's called propagation of uncertainty.